My name is Atul Arya. I work for a company called Panasonic, and I'm here to take you through the next session, which is titled as Who is in Charge? So you heard about sustainability and how sustainable it is, and electric mobility is one of the cogs in the wheel, which is trying to make the whole ecosystem sustainable for transportation. And we are here to discuss some topics around it. So let me first welcome the panelists on the stage. Arun Vinayak, who is co-founder of Exponent Energy. Arun, you're there? You here? And let me also welcome Govind Raj, product specialist Siemens. Govind. And by the way, we have a hybrid session here. So I have two of the panelists joining us online. Sanjeev Gupta, Executive Director, Head Corporate Strategy, IOCL. We will see him on the screen in a while. Hi, Govind. And we also have Dr. Prabjot Kaur from a startup in battery swapping space from Esmito joining us. So I guess we'll have to wait for them to start. But while we wait for them, let me also set the context here. Okay, so can we center align them? Okay, excellent. So, welcome Sanjeev and Dr. Prabjot on the panel. We would have loved to have you here physically, but because of your constraints, you are not here joining us physically. So, as all of us know that Indian mobility space is today essentially actually very excited about electric mobility. We have a lot of companies working in this space, making electric two-wheelers, electric cars, electric buses. We're talking almost everything electric, which is primarily about green and sustainable. Now, this has also multiple challenges around it, and one of the challenge is also to keep them fueled all the time, the way you go and actually fill up your petrol tank or a diesel tank. How do you do that? And while solving this problem of sustainability, there is another problem which has been created, that how do you do that? And there are multiple technologies around it. So we have experts here, Arun, Govind, Sanjeev, and Dr. Prabjot, who are trying to do their own different hypotheses and different products. And we'll hear more about it from them. And yeah, I think, so primarily, you know, this complex problem needs to be addressed, and we'll attempt to find a solution to this, or at least enlighten ourselves. So maybe what we'll do is all the participants will go one by one. So maybe a couple of minutes, you guys can introduce yourself, what you guys are doing briefly, as your company is doing, and then, you know, maybe I'll throw some questions towards you, and then we can address. So maybe Arun, your name starts with A, so maybe alphabetically we can start with you.
Yeah, all right. Thanks, Atul. Thanks for having me here. I'm Arun. I was previously the founding partner and chief product officer at Ather. We started Ather in 2013 because back then no one really believed in EVs, and we said, you know, if you can design and build EVs the right way, they will be better than petrol scooters. And that's what we did. And today, I think EVs are fantastic. On the drive side, what's not to love, right? I think what's holding back adoption is everything around energy, like you said. So 2020 decided to start Exponent. Got a little excited about how do you make energy seamless. Energy today is so complicated for EVs, so our focus is to simplify it, make energy fast, seamless. We charge vehicles in 15 minutes, so you can recharge like you refuel and just keep doing what you need to do. And I think that's what's needed to unlock all of India to go electric. And of course, we do this while ensuring the battery lasts at least 3,000 to 4,000 cycles, which is the first question I normally get asked, so putting it out there. Thanks. Thanks for having me.
Thanks. Govind, maybe you can go next, and then we go to the virtual panels.
I'm Govind, so I'm representing Siemens e-mobility business. I am working as a product specialist for e-mobility products as well as the digital solutions. We don't just sell the charging stations alone to charge the vehicles. We also offer various digital solutions for e-bus depots and e-trucks and so on and so forth. So these digital solutions are really the current market needs, which monitors, manages, and also operate the charging stations and address various KPIs what the bus depots will usually end up with. Yeah.
Thank you, Govind. Dr. Prabjot, do you mind talking about yourself and your company? Maybe you'll have to hang on for a second. I think we are having some problem with the audio, so just one second. Can we hear her?
Can you hear me now?
Yeah, go ahead.
Okay, great, wonderful. But it's echoing to myself, so I'm hearing my voice as well. Okay, I'm Prabjot, and good to be connected to all through this online media, and apologies that I couldn't be there physically to attend the event. I'm co-founder of SP2 Solutions Private Limited and started my journey with Center for Battery Engineering, was the founder and the CEO director for the Center for Battery Engineering and EVs at IIT Madras. From there, developed a few technologies which we licensed and commercialized through different partners. And that's where and when that I thought that I can have my own little startup and let's play the game of entrepreneurship that I was always interested in. In Espeto, the aim is to develop some highly efficient solutions which are much suitable for Indian environment and Indian society. So we do swap solutions, providing quick recharge or the reshuffle of the batteries with your discharge batteries while making sure that the batteries are safe. The other two products that we have are the battery management systems that we do for both NMC and LFP batteries, and which are recently, compliant to the recently standard, that is AIS 156 for the batteries for all different variants that we have. And whatever we do, that is swap stations or batteries, this is integrated to our digital platform. I was hearing that people were talking since morning about the digital twins. That's what we do. So we figure out that what happens with the safety of the battery, how early we can predict the life of the battery or any safety threat, and how do we prevent. So our controls are not only for monitoring, but also to actually control and probably predict and take preventive actions to control any kind of thefts, any kind of safety issues that arise from the battery. Thank you.
Thank you, Dr. Prabjot. And Sanjeev, thanks for being so patient. We would like to hear from you now.
I think since my childhood, I have been always waiting to be the last in the class. So, quite habitual of that. So, first of all, thank you, Atul, for inviting me. And ladies and gentlemen, I am Sanjeev Gupta. I am Executive Director and Head of Corporate Strategy in Indian Oil. So, as you know, Indian Oil is a major in oil and gas. So, I am contributing my weight in making oil and gas company to be energy company. So my work is entailing IOCs for in battery technology, entailing in battery charging, swapping, as well as hydrogen, including renewable power. So this is what I am doing. That's all, including like identifying partners, technology mapping, global M&A, joint venture formation, and running those companies. Thank you very much.
Thanks, Sanjeev. So we'll anyway hear more about what you guys are doing specifically in the mobility and charging space. But let me come back to you, Arun, again. So you said that you are doing rapid charging. Is that correct term to use, right?
Yes.
Okay, excellent. So 15 minutes is rapid. Yeah, but it's quite fast anyway. So why rapid charging?
I think rapid charging is inevitable, right? I look at this as an energy supply chain. So as you have more vehicles with more batteries on the road sucking more energy, you need to learn to transfer energy from the grid to the vehicle faster and faster. Now you can say, okay, I'll swap the battery, but let's say you have a swap station and you have 4 vehicles come in and out every hour. You need to rapid charge the swap battery, right? So however you look at it, rapid charging is inevitably needed. So we said, might as well solve it. Rapid charging just unlocks a whole bunch of benefits, right? Today, one of the biggest problems is the battery sizes. OEMs have to sell vehicles with much larger batteries to combat range anxiety, making the vehicle expensive, heavy. The other bit on the charging network side is charging networks don't make money, right? I take a piece of land, I set up a charger, I sell energy to 3 or 4 vehicles a day. It's not enough energy to make money, right? So counterintuitively, I have to charge a premium to the end user. So the rupee per unit on public charging today is so expensive because of the speed of charging. So we thought rapid charging unlocks both, right? You can make charging profitable, make energy affordable for the user, build a sustainable network, while on the other end, enable vehicles with smaller batteries, lighter vehicles, which is sustainable by itself, and make the vehicle more affordable upfront. So I think it sort of helps clean up. Of course, the flexibility and the fact that you can just keep going is important for most segments like logistics. So that's our target.
So what you're saying, Arun, essentially is that you are trying to actually help by reducing the size of the battery on a vehicle, which is typically standard. In absence of a rapid charging, you would have X size of battery, but now you can have lesser than X. Is that correct
Yeah,
understanding?
you can have 30% lesser battery
30% lesser.
while doing almost 2 to 3x more kilometers. So that's what we do in the road today. Our customers do 150 to 200 kilometers a day, while a conventional electric vehicle does something like 70 to 80 kilometers a day with a larger battery. So you sort of higher revenue, lower cost, right? That's
Sure.
important.
Understood. But how about the cost of a charger? You know, since your charger is also much larger in terms of power and energy throughput as such. So does it really not balance the cost somewhere, or you think that this is not a big difficulty?
No, actually our energy is cheaper. So today most public charging networks charge anywhere between 20 to 24 rupees a unit. We're able to sell energy at 12 rupees a unit, right? The biggest cost in a charging station is the land and the real estate cost. So that remains the same. Overhead costs remain the same. Whether you're doing a slow charger or a rapid charger, the cost of maintaining it remains fundamentally the same. Sure, the charger by itself gets a little more expensive because it has more power capability. The infra cost does go up a little bit. But then as compared to 3 or 4 vehicles, you're now charging 30, 40 vehicles a day. So, and that completely changes the economics.
So what you're saying is that even if it is capex heavy to have a rapid charger, but on the overall life cycle of this during the day, it makes up for it.
Yeah, and yeah, exactly. So it's not even like a long-term TCO benefit, right?
Got it. Anyway, I will leave it here right now and maybe directly go to Dr. Prabjot, because she's doing actually something which is right opposite to you, and you said that, you know, instead of rapid charging, you could actually do swapping. So why swapping, Dr. Prabjot?
Yeah, so I would not say that this is exact opposite of it. I would say it is quite complementary and probably or an alternate solution to provide rapid charging, actually faster than that. However, the use cases are different. So I would say that I mean, India is a primarily two-wheeler, three-wheeler driven market. 80-85% of the vehicle mix that we see as two-wheeler and three-wheeler, and primarily driven by affordability. Now, it is actually for those people who would want that the upfront cost of the vehicle becomes lesser. Now, as Arun was mentioning, that you can reduce the battery size to 30% and I mean, take care of the fact that you can charge it rapidly, so that at any number of distance you want to go, you keep on charging. Now, imagine for the scenario where you can completely get rid of the battery cost, right? So upfront, your vehicle becomes 40%, 50% cheaper, because that's the amount of the expense that you put in, that the capital that we put in right upfront when we buy a vehicle. So it is the upfront, the capex that any user puts in is about 40%, 50% cheaper. And it is available, the battery is available on the go. As and when your battery is getting discharged, you reach a swap station and just swap it. So it is to the end client, the use case is very important, especially from point of the usage point of view, where we have commercial users, delivery boys, running on two-wheelers, where both the capex as well as opex makes a lot of sense. So it is actually good to have thing for wherever we see that you require higher efficiency, you require safety, because in the long run, whichever are your type of battery, you cannot run those batteries, I mean, charge, discharge n number of times, because the battery would become unsafe. And at certain point in time, they'll just tell you that I'm not really good to be driven more, because the batteries need rest, much like human beings. So if they are not put on to rest, they are going for a toss, their life is impacted. If you start charging, fast charging a battery, which is not meant to be fast charge, but it is meant to be slow charge, and we do not have batteries which are actually meant to be charged fully in 15 minutes or 45 minutes, and eventually actually in 1 hour as well. So it's a great threat to the batteries, and in temperatures when we operate, like in our country, that becomes even more threatful, that becomes even more dangerous, and that's where the swapping plays a very, very important role. The other part of it, where we keep saying on the safety part of it, and we keep hearing about the news, the usage of the battery, etc. So if the batteries are in possession of an operator, and you have a good system to take control of the batteries, where you are always monitoring what is happening inside the battery, And based upon their internal characteristics with all the parameters that we monitor on our platform, if you're monitoring that, you know that how you should be charging. Even if you have rapid chargers installed into your station or slow charging that you can enable, can I control the rate of charge based upon the health of the battery? So such decisions, if these are concentrated at one location, that is at an operator's level point of site, that is where the advantages of swapping come into picture. You can extend the life of the battery, you can make the batteries more safer, while at the same time you can provide promised deliveries to the users as well.
Got it. So thanks, Dr. Prabjot, but just a follow-up question on this one. You said that you can actually completely reduce the cost of battery. Is that really true? Because when you are swapping, you actually have to have some of the batteries in the swapping stations also, literally. I mean, if you have, let's say we talk about 100 scooters, then you have 100 batteries in the scooters, but a percentage of those batteries should be in the swapping. So is that a correct understanding that, you need more batteries or?
Okay, so I'll explain on that. So in fact, there won't be, if it is that we have to serve as an operator to 100 clients, it is not that we have to maintain 100. In fact, we'll try to maintain 140, 150 batteries to serve 100 scooters, because you need to have the surplus batteries with you.
Sure.
Now here, when we say that the cost reduces, this is the upfront cost of buying for the users
Got
that is reducing. But yes, to provide the services for the same batteries to those users where the capex for those users is reduced, the onus comes on to the operators. So the whole of the assets comes on the books of the operator. So for him, the TCO needs to make sense, and if he operates, makes money, I mean, he needs to make money from this business of battery as a service, or you can say energy as a service. So we enable the operators who would like to set up this as a business, because this again is a very lucrative business if you have some captive usage, or you have some good clientage that is fixed, because ultimately it depends upon how much is the swap factor per battery of usage that you are providing.
Okay.
So again, to emphasize, when we say that the upfront cost of the battery is getting reduced, it is actually for the benefit of the user who is buying the vehicle without the battery.
Understood. Okay. Thank you very much. I think that's a good clarification. Sanjeev, I want to come to you and understand what is IOCL doing, because I know you guys are doing something on aluminum air batteries, and which is entirely different from taking the batteries to the chargers or doing the swapping the way Dr. Prabjot is doing. So what exactly is this? Can you explain it to us first, and then we can ask some more questions?
I think first of all, Atul, we are doing all three. So we are going into primary battery, which is aluminum here. We are also going in very big way in battery charging, and we are also going in a big way in battery swapping. So we are doing all three. However, if I look at the chronology, we started, first our approach was to map what battery technology we should be in. And why IOC decided to go in battery technology? Because the way we are following the process of producing our own oil, distillation and then selling it, we don't buy petrol, diesel and then do marketing, we produce. So our model was same, that in terms of energy, we'll also produce our own battery. And while doing this mapping way back in 2017 and 18, we realized that we need, as a public sector also, though we are a commercial organization, we should do something which is really suited to Indian market and Indian conditions. So based on mapping, we realized that metal air technology can be a very good option. And after that, aluminum air, particularly because India is one of the very major source of aluminium. And as I say, the aluminium is the one thing, almost 8 to 9% of the world metals, aluminium is the one source. It is very abundantly available, very suited to Indian conditions, and it's a primary battery. It doesn't depend on both charging or swapping. Yes, it entails certain infrastructure. So we started working on it, and finally IOC decided to go ahead. We invested in the Free Energy and also formed one joint venture last year, Indian Free Energy Private Limited in India, where India was a 50% partner. And right now we are running both prototyping and integration with most of the auto majors in India, particularly because this technology is much more suited for four-wheeler, buses, as well as three-wheeler. We are focusing on that. That's what we are doing. In terms of charging and swapping, yes, charging 10,000 chargers we intend to set up in next 3 years. That is what our chairman has given as a target. And battery swapping, we are running a pilot with Sun Mobility, and we intend to go ahead and set up this across our retail outlets, which are more than 35,000. So this is what right now Indian Oil is doing.
Thank you, Sanjeev. So we understand clearly that you've chosen aluminum here because aluminum is in abundance, and I think you are trying to address a very important question here that with all these lithium-ion batteries, we all know that there's going to be there's already a scarcity of metals which are concentrated in some parts of the world and not really everywhere. And here is a metal which is very abundantly available, and it is also available in India. So it's from the security of energy point of view also very important. But tell us, how is it different from the lithium-ion batteries, and what is it that makes it different from it, apart from the raw material, in terms of operations? What kind of vehicles it is suitable for? What kind of ranges does it give, etc., etc. If you can.
So I think, Atul, let me first clarify that this technology doesn't compete with lithium-ion directly per se, because this is a hybrid solution where we have a small lithium-ion. Because aluminum air technology, this battery is very good when it comes to energy density, almost 2 to 3 times of lithium-ion. However, it's very poor in terms of the power density. So it needs a mixture of both. So that's why it's not competing. Second point is, normally aluminum air is called range extender. So just to give an example, that we have run with pilot prototyping integration with one of the auto OE. So there are 3-wheeler which are running around 80 kilometers. With this battery, hybrid battery, can run 550 plus kilometer in one go. So this is the advantage. Second, of course, as I said, material is the advantage. Third advantage of this battery technology is that it is not affected by the temperature, which is also another issue in lithium ion. So these are the issues. Of course, it would need certain infrastructure in terms of availability of the aluminum plates or electrolyte that is there. So what I will say that this would be complementary to the lithium ion, wherever lithium ion has issues, like say you are running a bus. So purely running lithium ion bus, it means a very large weight you are dedicating to the battery. Whereas if it is run in a combination with our battery, the weight will reduce. The overall battery energy density will be much higher. We can run for a longer period. So I think these are the complementary where we feel that the gap which lithium ion is not able to fulfill, this battery will be able to do that.
No, I agree with you. I think with the extension of range, the requirement of setting up infrastructure also is lesser, because then you need to take it very limited time for the charging or refilling the fuel. And I think that's a very important fact. I will have to go to Govind now, because Govind has a very, very different, his company is doing very, very different things in this space. So you do chargers, and you of course provide solutions for swapping and variety of other things which are digital solutions. So we would like to hear from you, since you are agnostic to any of these, right?
Certainly. So let me start with the battery swapping itself. So it's not a solution that has to be superior than something else. So it's actually a complementary. It's complementing to various segments of EV business itself. So we have to be very, very much clear that the battery swapping is not something new. Okay, this was existing, or this was proposed as early as 1896. Okay, and they offered as a service, or the battery as a service was offered to e-trucks somewhere in 1910 to 1924. So this was an existing business model to everyone. And now we are talking about a fast charging, which is probably the advancement towards the power electronics and all such domain. So now when I have to compare these two, yes, the battery swapping has its own advantage. So let me put the advantages up front. So what are the major problems that we see in today's EV business or electric mobility? Is that range anxiety, charging time, and then the infrastructure. So if I have to set up a charging infrastructure, I have to look for the parking space, right? That's quite difficult in urban Maybe in rural, it's still possible. But in cities like Bangalore, it's really difficult to manage a parking space, and then if I have to look for 5 charging stations, then think about the space that is required. Second thing is, as Prabhujot mentioned, like we don't have to pay the upfront cost for the battery. The batteries can be still taken from the swapping stations, and the OEM of the vehicle can still send or still dispatch the vehicle without a battery, meaning that we lose or we save roughly about 30 to 40% of the upfront vehicle cost, which don't have to be invested by the EV owners, and still it will be on the par of the swapping station owners or swapping station managers. So now the third point is that I could still charge the batteries located in the swapping stations when the energy cost is low. I don't have to really look at, okay, today I have to run somewhere, I have to go quickly charge, but probably that is a peak time, I may be still billed at 20 rupees per unit. But in case of a swapping station, I don't have to look at these factors. I can still integrate my swapping stations to a renewable energy, make sure that whenever there is an excess or abundant energies left over, I could still charge them and keep them. So this will avoid the peak shaving, and it can also help in valley filling of the electrical grid. So this comes very powerful. And then once I'm charging at a non-peak demand, then obviously my charging capacity or the charging
cost is also
cost
low.
is very less. And eventually I transfer this to the user who's charging that. So that's the one part. So now on the other side, why we are really stressing on the rapid charging or a fast charging is that think about a long haul truck who has to travel all the way 1,000 miles. Probably he will take 2 or 3 breaks. Imagine the battery capacity that a long haul truck has. It could be in the range of few kilowatt hours, like roughly about 500 to 600 kilowatt hours is what the battery capacity that we can expect on that. And if I don't have a fast charging capacity, obviously I will get to charge my electric truck for about 3 to 4 hours, which is practically not possible. And that's when we are talking about a technology which can even charge the battery in megawatt. So let's not talk about a kilowatt charging here, let's talk about a megawatt charging system. So that's what we are upcoming trends are towards MWS, that is megawatt charging system, which is capable of charging in any electric trucks, which is having quite a large battery size in a matter of few hours, which is then a required break time for a driver when he has to travel all the way for about 1,000 miles.
So very interesting. I think we are talking about two-wheeler batteries, and then now you are talking about megawatt hour charging. But I have this question to you and as well as to Arun, is that of course we all understand that there is a rapid charging or a fast charging solution, which is extremely important because it adds so much of value not just to the vehicle by reducing the battery size, but also on the charging services. But how about the grid stability? You know, when you say megawatt charging or when you say 15-minute charging, right? Given this current state of the grid infrastructure, do we really have that kind of a backup available, or do we really need to strengthen it, and how long does it take, how expensive it is? Sorry, I'm asking a long question. At the same time, I have a pressure from the organizers saying that there are only 5 minutes left, and I have 5 more questions, so please.
All right, so quick answers. I think going back to the energy supply chain, grid to road, right? Between the battery and motor, things are solved, EVs drive fast, great. But every layer before that needs solving. Like I said, you could either buffer up by doing swap, but you still need to rapid charge the swap battery, and which still means you need energy from the grid. So like I said, more vehicles on the road sucking more energy. We need to re-engineer every layer of the energy stack the way we look at it today, starting from sort of just going away from the conventional wisdom that rapid charging is bad, it's unsafe, or you can't pull energy from the grid. These are not true. They need deep engineering solutions. You can't just copy-paste technology that works in the rest of the world. You can't just buy regular cells. You've got to innovate on battery tech. We have to innovate in charging tech. We also innovate on the back end of the charger tech, which is something that we're forced to do, right? So a rapid charger needs, let's say, 100 kilowatt of peak power, but you actually need roughly 24 kilowatt of steady state power, just rough examples. So it actually is commercially bad for you to draw 100 kilowatt of power from the grid, right? And pay for that demand charges month on month. So if not for anything else, I think organizations always solve in this commercial incentives. So I have deep belief that this will get solved, and a lot of companies in the world are solving for back-end power buffering, etc. So I think every layer of this stack that we look at it today will be different.
Understood. Govind, what about you? What do you say?
That's when we call it a digital solution, right? So we, of course, have a solutions to meet all these criteria or to overcome these problems. So we have various smart charging algorithms put in place. We will make sure, or the digital solution platform will make sure that we don't draw energy or we cap or limit the energy consumption when there is a huge demand which requires a higher priority. So that's when we always see, okay, this is my priority, and based on the influence that is given or driven by the grid or the operator, we will substantially look for what is required on the ground level. So we don't, though we have an energy requirement on the electric vehicle charging, we will make sure that the prioritization on the main operator is always considered before we offer a solutions or services to them. So that's when our digital solution platforms will come into the picture.
Excellent. Thank you very much. So I have two very quick questions, rapid fire questions as we can call them, and I want response from you, Prabjot, Sanjeev, everyone. What about the safety of the battery? That's question number one. When you do rapid charging or swapping, or Sanjeev, you do charging and swapping at your petrol station. So I think there's a different dimension to that, right? So that's question number one. And second, about standardization. If you can take 30 seconds to answer these two questions one by one. Arun, you can start and then.
So I don't believe in standardization. I think OEMs should use whatever batteries they want, different sizes, different shapes. Standardization kills innovation. Like imagine asking Hero, Honda, Bajaj, all of you to use the same engine. No one's going to sign up. The industry will die overnight and there'll be no competition. So same way, I think just bringing in some standards or even protocols around charging is more seamless. And every OEM can have a different battery, different cell manufacturer, different voltage platform, different shape, size, So I think that's the most important thing. We're in a very nascent stage in the industry. You need healthy competition for the industry to grow. And so big believer in not trying to over standardize batteries, because then there's no interest left in the industry. Second, around safety, I think safety is critical. I think safety is such a low threshold. When you're rapid charging a battery, it's sort of like a Lewis Hamilton being your Uber driver. If you want to go fast, safety, the sort of responsive systems and the sort of accuracy in detection that you need is so high that safety comes for free. So I think we should sort of decouple these discussions, right?
All right.
So
Understood. Govind, you go.
At least from my opinion, standardization is must. Rather standardization, I would call it as compatibility. I cannot use X with Y.
Interoperability, as they try to call it.
Yeah, that's very important for me. Of course, safety is the first, and of course, each and every manufacturer or OEM are taking enough precautions in bringing them before reaching out to the customer. So it is very well tested, and they have to go hand in hand. And I would say safety first, and then interoperability is must.
Thank you very much. Dr. Prabjot, you.
Yeah, so if you ask me, I think I'm a very, very strong believer of standardization. I was the panel convener of the swapping standardization at BIS. So especially for swapping swappable batteries and swappable solutions. And I think as far as we go for swapping, charging and other things, we can still standardize things for performance, for efficacy, for safety, without compromising on innovation and creativity. And one straightforward thing to do or to address this is that define the safety standards and minimum performance standards, which are mandated by any OEM or a supplier to be adhered to, and leave a good scope of innovation and creativity. It is not that if I say that your watt hour per kilometer or whatever standardization I'm fixing, it has to be this. It can be anything beyond it, but the minimum standardization, minimum limits for the safety, we must adhere to, and whatever we manufacture, even if that is a startup, a big OEM and an MNC, they have to adhere to standardization, because without that, randomly we cannot keep launching anything and everything, especially if like a battery, a lithium-ion battery, high energy density battery, if we are sitting on something like a bomb riding it unsafe and without going with any unchecks, I think that is very dangerous. So yes, standardization plays a very important role, especially from safety point of view. And as you asked on the safety, very quickly, the digital twins help a lot. So whatever we do, I think at this point in time, if we do not keep in mind that we need to monitor everything that we have, all the assets that we have, especially from the dangerous goods point of view, or we need to have a good battery management system. We need to capture good data points and make sense, which can actually alert much ahead in time if there is any threat one could see.
Thank you.
So those are my 2 cents. Thanks.
Thank you. Sanjeev, you have the last word.
Yeah, so I think as far as aluminum here is concerned, there is no risk of safety because aluminum anyhow is non-reactive, and electrolyzer what we are using electrolyte that also is, so there is no issue, temperature is not an issue. Coming to your second question, as far as battery swapping on retail outlet, so I think one very important aspect in our pilot had been a very thorough study, and that's what we are running with Sun Mobility, and I think the one important criteria was the safety part. So I think that goes without saying, and it becomes much more complicated when you are using this solution at our retail outlet.
Thank you very much. I think I must thank all of you to first of all participate in this and actually open up a lot of new ideas and new discussions around it. And yeah, I think I didn't expect that you will all agree on all the things. So, and it is evident that some people don't want standardization and some people are big fans of standardization. I think
Safety standards good, standardization
of course.
bad.
Yeah. So absolutely. I think this is where it is, and this is and as I understand that the petrol or the IC engine industry is very old, and still there is a lot of problems and issues which are coming up. A lot of solutions are coming up. A lot of new innovations are happening. And electric mobility industry is actually a small baby. So we are all learning, we are all discussing this, and I think that was the objective of this panel discussion, that we discuss some of the very important issues, hear all of the experts who are here. And yeah, thank you very much to IET, FTC and all the panelists once again. Really appreciate your time and discussions. Thank you.